Hi there guys, welcome to a lesson on classes, objects, loops, exceptions. So, first of all, we're going to be starting out with classes. Okay, so what is a class? A class is a blueprint for an object essentially. A class is what we use to create objects. These two topics here are very closely linked. So, I'll give you an analogy, an example of this, okay? So let's say we're creating a blueprint for a car, okay? So this is our blueprint of a car. So first of all, for our blueprint, we're going to have attributes. For example, we're going to have fuel type, we'll have top speed, we'll have make, and we'll leave it at that for now, okay? So these are what we call attributes. Okay, so in both our class and this, these are what we call attributes. They describe our what will eventually be our object. They will describe the object. They don't do anything. They're just values that describe the object. Now, our car can also do things and have things done to it. Okay, so we call these actions normally. But here they are methods, okay? And the methods that we're going to use, we're going to have drive, and we're going to have refuel, okay? So now our car can have a kind of fuel type, have a top speed, and make. It can also drive and refuel. Now, in order for these to be effective methods, we need to add two more attributes, okay? And these are fuel level and mileage. However, these are separate as we don't need to pass these when we're initializing the class. The fuel level will always start at 100 because cars normally come to you fully fueled, and the mileage will always start at 0 because the car has not yet been driven if it's a new car. So let's create this in Python now. Okay, so to define a class, we just write class. We're going to call this car. Okay, now, first of all, we need to create a constructor. Okay, this is what's going to build our blueprint into an object. Okay, and the way we write a constructor in Python is by going def underscore underscore init with one n underscore underscore, and in here we'll need to put self. Self represents the object. This means that all of these methods will be done using the object itself to do them. Okay, I know that sounds complicated, but it will make sense when I start using the attributes. Okay, so attributes that we're going to need to be inputted are: we're going to need the make, we're going to need the fuel type, and we're also going to need the top speed. Okay, now we've done that, we need to initialize these into the attributes of the object, because currently they've just been passed but they've not been put in anything. So we're going to have self, if I can spell, self.make is equal to make, like that. Okay, and this is just saying our car, has an attribute called make, and it's equal to this make we've been passed here. And then we're going to have self.fuel type is equal to the fuel type, self.top speed is equal to the top speed. Okay, now our two more attributes here. Okay, so we can actually just copy these, but we'll need to put self because we're setting it as an attribute of the object, not just a local variable. And there we go. So now we have initialized all of our local variables. Okay, so now let's do a test here. We're going to say polo equals car and in here we're going to put it's Volkswagen, it's petrol, and its top speed is 120. Okay, and now if we simply print polo.topspeed like this, let's run this, wait for the runtime to connect, we can see it prints 120 because that's what we set the top speed to. Let's print out the mileage, and that prints the mileage. Okay, so we can also edit these outside, but for this purpose here we're not going to be doing that. What we want to do now is we want to add these methods we laid out here. Okay, so these just take the form of more functions. Okay, so let's create our drive method. Once again, like all functions and methods within a class, you will need to take the self attribute. And then we're going to also take a distance. So how far are we going to drive? Okay. And we're going to say that, first of all, we're gonna check that we don't have empty fuel. So if self.fuel level is equal to 0, equal or less than, so we'll say less than or equal to, like this, then well, we'll also need to check that we can't outdrive it. So we can say, we'll say every 10 miles we drive is 1 level of fuel. So, or distance over 10 minus fuel level, like so, is greater than or equal to 0. That way we can never go below 0. So in this case we can do self.mileage plus equals distance, if I knew how to spell distance, and self.fuel level minus equals distance over 10. Else not, well, we can print out not enough fuel. Okay, so now let's run that. So let's say here input, we'll say distance equals input, and then we can say print, then we can say polo dot drive like this, and then we can print polo dot mileage like so. So actually before I do this I need to make sure I convert this to an integer, and also put it here, and now we can run this. So let's say we drive 20 miles. Self.fuel level is not defined. We seem to have made a small error. We forgot to write self. This is just a common error. Right, let's continue. And we're going to put 20 miles in again. And as you see, it prints out our mileage, which is 20. So that's pretty simple. Let's try and drive further than we have enough fuel for. So that would be 1001. There we go, not enough fuel, and we didn't drive anywhere, so 0 mileage. Now, let's add a refuel function. We'll assume every time you refuel, you just refuel to full. Oh, no, we need to put self inside the brackets. And we'll just do self.fuel level equals 100, and we can say if self.fuel level less than 100, do this, else print already full. Okay, so let's try to we'll try refueling 2 times in a row after we've driven and see what happens. Okay, so let's drive quite far. We'll drive 900. And we've got 900 miles, and there we go, already full because we tried to refuel twice. Okay, so we can see our program works pretty well here. So that's basically objects and classes. Now we can move on to loops. So there's 2 types of loops. We're going to start with a for loop. So commonly, for loops are used when you know how many times you want to iterate. So let's say we want to print hello 5 times. We're going to do for I in range 5. Print hello. Print hello 5 times. Okay, now if you've done the lists lesson yet, then this. If we have a list of fruit, I can't spell banana, so we're not going to do banana. We're going to do pear. We're going to do strawberry, and we're going to do orange. So we've got some fruit. If we do for fruit equals for fruit in fruits, print fruit, this will run through our list for us. Okay, so these are the main 2 uses of for loops. So I'll write out that second one again. For I in range 5. Okay. Now something to note about the I here, just like with fruit and fruits, if we were to print I, it would print 0, 1, 2, 3, 4, like this. Okay, so it goes up to just before 5. But as you can see, it does iterate 5 times like we asked. This is just a marker for which one we're on. Okay, so there you go. That's the for loop. Let's do while loops. While loops are like if statements even, that keep going while their thing is true. So if we say num equals 1, no, num equals 100, and while, actually, we'll do num equals 0, while num is greater than 0, print hooray num minus equals 1. Okay, so as you can see, it prints out 10 times because it kept subtracting from num until num was less than 0. Well, num was equal to 0 in this case. Okay, so they satisfy a condition. So we'll do one more example here. We'll go upass equals this, so user password equals that, while upass does not equal pass. That's what we're saying the password is. We're going to say upass equals input the password, print you got it. Okay, so let's try hello. Nope. 1, 2, 3. Nope. 3, 2, 1. Nope. QWERTY. Nope. Pass. Yeah, you got it. Okay, because we set upass equal to pass, this was no longer satisfied. This is only satisfied when it's not pass. Okay, that's when it loops. And as soon as it is pass, then it exits the loop and comes down to this. Okay, so now last topic we've got on our list today, exceptions. Okay, so exceptions are essentially errors. Okay, so I'll show you an example of an error. As you can see, name error. This is an exception. name is not defined, and it nicely tells us where it is. Okay, this could happen, for example, let's say we num equals input a number, and we try to do print number is plus num. Do 23. But in that case it worked. But if we try to do, let's say divided, it doesn't. It throws an error because it's got the type error. So we can do what we can do here is, if we don't want this error, we can say, or I'm going to say num1 equals input. Oh, I see what we did wrong here actually. If we put int here, there you go. So now we get an error. But if we put 20, now it gives us the right answer. But if we put a word in, it throws an error. So what we can do is we can do try except, not with a capital E. So we can do except type error like this. So that means it's wrong. We can say print input only numbers. So let's catch this out. So we're going to put hello. Oh, this causes an error here. I forgot about that. So let's go here, and we're going to say, instead of this, we're going to do eval actually, and then we'll try catching more errors in a second. Okay, hello. No, hello is not. It's fine. Oh yeah, this can't take string. Okay, never mind. Go here. Go int. Go value error, and this one will work. Here we go, and we caught the error. Okay, so this is the basics. If we want to catch a different type of error, we could try going except. If we turn this into eval, we can go name error, and we can say, we can pretty much say the same thing, because you'd only get that if you input the wrong thing. Let's try true. Interesting. Let's try hello again. So once again, we caught the error, and we can say this is name, and we can say this is value, so we can check which one we're catching. And we'll try hello, and this time it was the name error we caught. Okay, so these are the basics of classes, objects, loops, and exceptions. I hope you enjoyed the lesson, and until next time.